Hi everyone. So now we're going to be beginning our discussion of sorting. Now in computer science, it turns out that sorting is a very important problem because it turns out that you actually have to sort lists of things oftentimes when you're writing programs. And it turns out that we don't want to sort things just anyway because there's different ways to sort a list. And depending on which one you use, they can be faster in certain situations and slower in other situations. And so we're going to begin the discussion of multiple different sorting algorithms which we can use to best sort a list. Now, the first algorithm that we're going to talk about is a common one, which is essentially called selection sort. Now, before we talk about selection sort, let's try and understand what selection sort is trying to do. Now, essentially, let's say that I gave you a list of 16 different numbers. So actually, we're going to be using this applet, which is made in Java by David Eckhart, and it's called Xsort Lab. You can go to the notes on the 112 website, and if you go to efficiency, you'll see that it has a link to this app. Essentially what it is it's going to visualize different algorithms. See, we have all these different choices for algorithms. So it's on selection sort. So what this is it says that it's a list with 16 elements, and basically the height of the bar is saying the value of the element. So the largest element in this list is right here. The smallest element in this list is right here. So what we're going to do is essentially sort this as fast as we can and try to make it going from smallest to greatest. So let's think about a way that if I just give you a list of numbers, what's like one way that you could sort it? So the way that I think is a good idea on how to sort it is essentially I have this list of 16 elements, so if I just find the largest element, I know that it's the largest, so I just can put it at the end. And then I only have 15 elements left, so I find the largest out of those, and I put that one at the end. So then I keep basically finding the largest element in what I have left and putting it at the end until finally I have no elements left, which means that I kept putting the first largest, and the second largest, and the third largest, all the way down to the smallest, and so it should be sorted. So if we run this algorithm, let's see that just does that. So first of all, it keeps track of the max. And basically what it's going to do is run through all of the elements, and every time it sees an element bigger, that's going to be the new max. So between these two elements, the bigger one is right here, so the max changed. It keeps looking, now it's a new max. And then again. And so now I keep stepping, and essentially I finally find the 15th element, which is the largest element. So now I put the max at the very end, and now because it's black, that's how it indicates that it's sorted. And so now we know that we're done with this pass, and the largest element is at the end. So now once again we run through and we find the new max. So if I run this, essentially what it's doing is going to keep running through and finding the max. So once again it found the 7th element, which is the max for the 15 remaining elements. Note here that it's not going to check the 16th element, because essentially it's already sorted. And so we now put that one there, and if we speed this up, essentially we're going to keep going through, putting the largest ones up in this situation at the end. And as you can see, the last elements, the ones in black, are sorted because we keep putting the largest we have left over there. And so, finally, if we look at what's going to happen at the end, it has a few elements to look over, and it's done. And so now it's sorted. So this is the basic algorithm behind selection sort. And if you don't get this completely, I highly recommend that you go and try this Xsort Lab because it's a great visualization. But now let's look at the actual code for selection sort. And the code for selection sort actually just mimics the algorithm very closely. So essentially we have this list A, and the list is of length n. So what we're going to do is basically loop through the list, and for each, basically the way you can think about it is that the outer loop is saying, I'm now going to try to find the max for the elements I have left for this. And in the algorithm, we have to find the max n times, because I find the max the first time, I put it at the end, and then I find the max the second time, I put it at the end, and I need to put each element finally will eventually be the maximum element, so I do that n times. So I do for start index and range n. So this is essentially where I'm starting from. Then what it's saying is, okay, the minimum element, so just a caveat, so it turns out that in this selection sort, we're actually going to find the minimum element and put it in the front. In the last selection sort, what we did is we find the maximum element, but it turns out that doing it either way will work. So here we say, okay, The minimum element is probably the one that I'm looking at now. And so now let me loop through everything else in the list. And essentially, what this for loop does is finds the minimum elements in the list that we have. Then finally, after this for loop, I say, okay, now swap that element into the start index. So actually, why don't we try and see this work on an example? Okay, so I have this list, let's say 3, 4, 2, 8. So what our algorithm is doing is essentially finding the minimum element. So the first outer for loop says, okay, this is my start index right here. And then what it's going to do is say it's also currently the minimum element. And so then I check this element, and I see that 3 is still smaller. Then I check 2, and it turns out that 2 is smaller. And so now my new minimum element is 2. And then I check, is 2 smaller than 8? And yep. So now finally, I've basically checked all of the different elements, and I found the minimum. So now what we do is we swap this 2 with the 3, because the 2 is the smallest element, so it has to go in the beginning. And so now we end up with the list 2, 4, 3, 8. So now with this list, I know that this element is sorted, so everything before this is sorted. And so now my new starting index is the next element, 4. And this makes sense because essentially now when I find the smallest element, I know that it's going to be bigger than 2 because 2 was the original smallest element. But now I want to put it in this new start index. And so if we go back to this code, essentially it's doing exactly that. It moves the start index from 0 up till n, and then it keeps putting the smallest element in the new start index. So this is the general algorithm for selection sort. I highly recommend that you walk through the code yourself and convince yourself with examples that this actually works. And once again, remember that in this code, we're doing it by finding the minimum and putting it at the front. In the XSort lab, we do it by finding the maximum and putting it at the back. But you should think about how this is actually both doing basically the same thing. So this is our first algorithm for sorting that we've gone over, and now in the next videos, we're going to talk about a few different ones.